Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good day to all my beloved students. This time we will do the exercise related, of course, heat transfer radiation, spectral emissive power. So this is the question. We are given a diffuse surface at 1600 K has the spectral spherical emissivity shown as below. T or temperature 1600 Kelvin, lambda 1 or wavelength 1 2 micrometer, and wavelength 2 lambda 2 5 micrometer. So this is the graph, which is we can refer from here. This epsilon 1 or emissivity 1, which is 0.4, and this one is the emissivity 2, emissivity 0.8. Okay, so this one is 0. The question, determine the total hemispherical emissivity and total emissive power. To solve this question, so we need to know a few terms or the equation related to this problem. By having this information, T lambda 1 and lambda 2, the general equation we can denote as emissivity equal to the integration of emissivity lambda and the emissive power of the blackbody over the emissive of blackbody. Knowing that from the equation, it divides by the value of the wavelength, which is 0 until 2, 1 value, and then the 2 until 5, another 1 value, which is we need to total or sum up for the emissivity 1 and the emissivity 2. Or we can use this equation, emissivity, the total emissivity, refer to the emissivity 1 and then function of the body 0 until 2 micrometer, so this one, and then emissivity 2, this one, with the function of the 0 until 5 micrometer, okay, here, and then minus 0 until 2 micrometer, which is here. Maybe we can have a look how to calculate the detail for each case, referring to this one, and this one. Bear in your mind, if you get this figure, which is it can be replaced to this part, because with the same value, right? 0 until 2 micrometer, so this one also 0 until 2 micrometer. So from this information, lambda 1 times T, okay, so lambda 1 2 times T from the equation 1600 Kelvin, and we get the 3200 micrometer Kelvin, and then by having this information we refer to the blackbody resonance function, which is from here we can see that this 3200 micrometer Kelvin is somewhere over here, which is the F is 0.318102. So it's straightforward to get this number, this function of the radiation blackbody. And then with the same approach, we try to get the other number of the spectrum. Okay, so inserting this F function 0 until 2 micrometer, which is equal to 0.318, we can insert here. So this is how it look like. Actually, we can have the information this one, epsilon 1 refer to the 0.4, but later we will insert this value later. Next, we try to determine the lambda 2 times temperature, which is from the graph we can see that the lambda 2 is the 5 micrometer, this one, times from the question T is given 1600 K and we get 8000 micrometer Kelvin. And then with the same approach, we refer to the Blackbody radiant function and we try to look at that 8000, which refer to the 0.856288. So in other words, function from 0 until 5 micrometer equal to 0.856. Yet, insert all this information in the equation and then we can get this detail, which is 0.4 refer to the epsilon 1 or emissivity 1, 0.318 from the f or function of 0 until 2 micrometer, and then 0.8 refer to the second emissivity, and then 0.856 is the function from 0 until 5 micrometer, and then minus the 0.318 to get the final answer. So based on cell calculation, I get emissivity equal to 0.5576. Next, to calculate the total emissive power, from the general equation, emissive power equal to the emissivity times the Blackbody Blackbody power, which is sigma or Stephen-Boltzmann equation times with the temperature power of 4 and also times with the emissivity. From the previous information, we can straight away insert all the information by having the number of the emissivity 0.5576 times the Stephen-Boltzmann equation 5.67 times 10 power of negative 8 and times with the 1600 Kelvin power of 4, and finally we get the final answer 207.2 kilowatt per meter square. So next, this is the most important part. You guys can try by your own with the same question, just the matter of changing the temperature value instead of 1600 Kelvin to 1520 Kelvin. The rest remain the same, which is the lambda 1 2 micrometer, lambda 2 5 micrometer. And of course, so we'll give you guys the final answer, which is from my calculation, so obtain 168 kilowatt per meter square. So if you think or you get the different answer, maybe on my part I'm wrongly calculate or maybe typo or something, so you may mention all the correct answer in the column or in the comment. With that, thank you very much. All the best. Assalamualaikum warahmatullahi taala wabarakatuh. Thank you.